Guys, so you know this episode of the Motivator Project is called bearings and shafts and hubs. Hold on. Here's the hubs. Here's the other 5. If you watched the video, you saw that there's 2 of them will hold gear on one side and a wheel on the other side. But this particular aspect of it, the way I'm doing it, you pretty much have to have a lathe and a mill. I mean, you could drill all the holes. You could bore it out, you know, with anything. You know, find a big drill or something, torch it out, weld it together, and get it to work. I'm not saying that won't work. You can do that. But I like a bearing set. Let me zoom it in again. If you can see this. Too far away to really see, but there is almost 0 run out here. So when the wheel's on there, it'll look like it turns straight. The only thing I have left is on these shafts. There's 6 of these shafts, and they need a 3/16 or a 5/16 keyway on either end, one for each hub and one for the bearings. So they need a 2-inch keyway on each end. So I'll have to chuck them all up in the lathe and go through there and run keyways through them. But yeah, it's almost done with this bit of it. I'm going to be going on vacation in a few days, so this video will be coming out, I don't know, 2-3 weeks away. It'd be after the first of the month before I do anything else. So if you are watching, thanks for watching. If you don't like it, tell an enemy. Maybe they don't like it. We can take it out on someone else. If you do like it, tell a friend. Thanks a bunch. I think I hit the wrong button. This guy right here is the one that I was working on first. Whoops. So this bolt pattern here is the bolt pattern of the wheel. And I want to be able to bolt this wheel to this plate. This thing will be hooked with a coupler onto the shaft, and it'll be turned by gear, and the wheel will be on here. So if you look at these circles around here, I did some measuring and determined that it's a 5-bolt pattern and that it's got a radius of 50 millimeter or 100 millimeter diameter. So I punched in the DRO and centered this, indicated it, and ran it through a 5-bolt pattern with that. And these little marks, these little dots, are the marks I scribbled on there with a Sharpie. And then I took it out and I lined up the bolt pattern on the wheel around those little marks. And that's how I check to make sure I got my math right on that bolt pattern. So next I'll show you how I punch it into the DRO. But I got to get everything set up first. Hey guys, look at my watch and see if I'm in here. So this is, let me grab one. Hitting stuff. This is one of the discs right here. It's going to be for the wheels. Here's one with holes drilled in it. I think I mentioned already the center hole, I put them in on the lathe, so they're very centered. I indicated down to 0, center. So then I use a pin that's the same size to indicate it, set it up here to drill the bolt circle. You see that? So this Chinesium DRO, it works pretty good, you know. Wasn't bad, I got no complaints, but down here there's kind of like a circle with holes in it, you know, bolt circle. Even if you don't read Chinese, you can read that, right? So you push it, and it's coming up. It's saying, is this just an X, Y coordinate system for this hole? And it is. It's just the X and Y. So I say yes. Now it's asking center position. Well, I indicated this IIL and set it all as 0. So its current center position is 0, right there. It's 100 millimeters in diameter. I already punched this in, enter. It says starting angle. This is where you'll screw up. I'm starting at 0, which happens to be on my right on the y-axis. And so I use 0 to start. 5 holes, divide 360 by 5, it's 72. So each hole is 72 degrees apart on a continuous arc. So 5 times 72 is 288. So I put 288 in there. Number of holes, 5. Enter. So now it's telling me I just move it until it zeroes this out, and I'll be on my first hole. I drill it. I hit the down arrow. It'll give me hole 2. I move to zero it out again. I do that 5 times. I got 5 holes. Really? Yeah, that's how it works. So, like I said, gotta set this guy to 0. And in this particular case, since 0 position is centered on the axis of the y-axis on the table, all I gotta do is move it, just release my little clamps, and make this 0. It's real close to the edge. Whoops, went past it. This is a trick on this mill. It is not a real precise mill, and I'm a little anal about getting it on 0. It's hard sometimes. Let's see. Well, minus 1/2 of a 100th of a millimeter. There it is. Okay, I'm on 0. Everybody else is locked down. So, oil. I'm doing this pretty much by hand. Look at it. I zeroed my Z-axis too when I set the drill bit into that hole in the center. So, since it's a 1/2 inch plate, and I'm reading in metric on the display, it should be around 13 millimeters when I pop out the other side. I take my time to keep it wet. Right around 10 millimeters right now. 11, 12. Yeah. So there's about 2 millimeters taken up by the tip of the drill, the angle. Right on. So then, chips on the mill's like junk mail. If you throw it away when it comes in, you don't have to deal with it at the end of the month. So yeah, 4 more holes. So I go up here. I'm done with number 1. Tells me now 0 both lines. I'll be at position for number 2. So this guy over near the x-axis. Zero, oh, right about there somewhere. Y-axis, whoops, take it to 0. Ooh, that is close. Oops, there you go. Getting into 0 is a hard one. Okay, see now I'm on 0, I can do another hole. Got it pretty close with the toe clamp. Clearance is clearance. Halfway through. So we're breaking through just shy of just over 14. 13, 14. Gotcha. And so it goes. Hey everybody, update on this on these hubs. So I think I said already, these are 5-inch diameter mild steel discs, 1/2 inch thick. And first of all, I had to put 5 holes in each one of them to fit this hole, the bolt pattern on the wheels that I got. Right, very nice. And then 2 of them have a 4-bolt pattern in the middle, fits the gear right there. So 6 hubs for 6 wheels, 4 of them are just going to connect to the wheels. 2 of them are going to connect to the gears and the chain. The 2 drive chains that go on the outside of the wheel frame drive one set of axles, but then on the inside there's chains that connect all the axles together, so it just makes it cleaner. So 30 holes 5/16 and 8 holes 3/8 natural course for the gear. So the next thing I got to do, I mentioned it. Let's see. So right here in the middle, I drilled a hole, and it's the hole that this pin, and it is just slips in there, and it's for an annular cutter that's 1 1/4 inches. And now I'm gonna punch these, all 6 of these out, punch a 1 1/4 inch hole in it with an annular cutter, and then I'll take it over to the lathe and chuck it up, indicate it in the 4-jaw, and I'll bore this out to the final size with the lathe. And then theoretically all the bolt holes in the center will be concentric, given that I indicated this thing down to within 1/2 thousandths around the outside edge of this slug. And this is a fairly accurate, it's 5 inches plus a few thousandths, but it's pretty perfectly circular. So that's the next step. Punch out the hole in the hub so I can weld on these couplers that will affix it to the shaft. Stay tuned. Alright, this is the next step. This is one of the drive hubs. You can tell because it's got 2 bolt patterns. And this is a 1 1/4 annular cutter. And I pointed out it's got a little peg in the middle, and it's real easy to, you just slide this in and slip it up where that peg lines up, and then drop this guy down and lock it, and then you can tighten your clamps and it's all centered. So now, if you don't know about annular cutters, they like to be wet, really wet, and they cut really good, but they make ugly chips, but it's the nature of the business, right? If you let them, they make real long, stringy chips. Like I said, you got to keep it wet. Now that I got a little groove cut where it's going to stay on its own, I just start feeding it in. Okay guys, this last step had a big space in the middle of it, and the reason is okay, kind of getting organized here. So I want to show you this. This is a Chinesium 3/16 by 1/4 inch long reach end mill that was extremely expensive at the cost of like $5. And it managed to cut 20 thousandths in that 4140 before it burned out the tip. So perhaps the guy that translated for the Chinese thought he was listing the things that'll destroy it rather than what it'll cut, but who knows. So I had to wait a while, went to McMaster Carr and got this guy. Solid carbide end mill. 3/16 by 1/4 by 3/16. There's the part number. Made in Germany. And that little puppy cuts really good. So I'll finish it now. But I'm taking little cuts because it's a carbide end mill and it's a small mill. And you got to be careful because I'm treating it like glass, because this end mill was $38. So I was thinking if I bought like 6 of the other ones, I still would need 6 more to finish cutting all this 12 grooves. So yeah, sometimes you got to get the right tool for the right job. And this is one of them. Well, there it is. It's the last dry fit. Shafts are done. All the keyways are cut. And the last thing I got to do is take all these keys out and radius the ends. So they'll fit in where that end mill left a round end. Tuck them in tight. Cool.